Now we'll talk about the models. There are several types of models to determine the distance estimate given the RSSI value. We can use regressions, polynomial fitting, freeze-based models, machine learning, and so on. Each of these have advantages and drawbacks, such as complexity, calibration data volume required, robustness, reliability, accuracy, and so on. We'll see a quick panel of some models. First, the fixed index freeze-based model proposed as a white paper by Interlink Networks is based on a study in a set of buildings in which they proposed a model based on freeze formula. So here is the adapted freeze formula. It's the same except for the distance, whose power here is 3.5, which accounts for the higher wave attenuation inside the building. However, with tests in other environments, we saw that it doesn't perform well for each and every building. Its properties are to have no complexity, to require zero calibration data, to be robust, to be reliable, and to have a bad accuracy. Then we proposed a freeze-based calibrated model, which is based and extends Interlink networks with a calibration. There, the fixed value is replaced by a value based on calibration, one value for each access point. So it's the I here. It's the I here. It's more accurate than Interlink networks, but not so much. So it's a low complexity. The calibration data volume is low. It's not robust because changes in the topology and the access points placement will impact the results. It's reliable, and it's a bit more accurate than Interlink networks. Now, the polynomial fitting, it will use a curve fitting between the calibration data presented as points with coordinates D as the x coordinate and RSI as the y coordinate. An example model here is D equals 0.000198 times RSI cube minus 0.025 multiplied by RSI squared plus 1.14 multiplied by RSI minus 14.8. It can give a decent estimate, but since it's not based on freeze, it's not similar to the real-world relationship between D and the RSSI. It has a low complexity, it requires few calibration data, it has no robustness since changes impact the results, it is reliable, but it has only a bit more accuracy than Interlink networks. Then machine learning will use a lot of training data of the calibration to input it to a meta model which iteratively improves its accuracy. Many models are used as black boxes because we don't know what exactly happens in it. For example, the artificial neural networks, deep learning, which is a subset of the artificial neural networks, and so on. Many underlying data of these models are unknown. It will output a relation similar to polynomial fitting, but with a high complexity, a high calibration data volume required, no robustness since changes will impact the results, no reliability, you have no error bars, and probably a bad accuracy.